you can see this is a fuel consumption rate of a car. So we are going to solve this problem. Look at this schematic here. This is actually the car engine. This is the combustion chamber. So we can say this is high temperature reservoir, and this is the atmosphere. We can say this is the low temperature reservoir. So what we can see from this schematic, the net work output, it is given 65 HP. So this car engine, we have this output, so it is actually given here. So look, the car engine with a power output of 65 HP, and the thermal efficiency also given. So that means, look, we know the output here, and what we know, it is actually 24%. The efficiency is 24%. That means whatever the heat we are getting from this combustion chamber, this heat engine, it can convert only 25% of those heat into the work. But here we don't know this Q haze. This is actually not given. But in the question it is asking, determine the fuel consumption rate. Okay, the fuel consumption rate if of this car, if the fuel has a heating value of this kilojoule. So this is the heating value. It says this 44,000 kilojoule of energy is released for each kg of fuel burned. So if 1 kg of fuel burned, then it will release this amount of energy. So what we need to calculate is, we need to calculate actually the this value, actually the energy rate, okay, the fuel consumption rate that we need to calculate. So here it is an interesting problem. What we can say, we can directly just start with the analysis for this problem. So here what we know, guys, we know okay, so what we know is, we know the, okay, I need to write it down again. So here this work output, it is given 65 HP, and the efficiency, the thermal efficiency, it is given 24%. All right, that we know, but we don't know this Q haze. So according to the question, whatever energy we are getting from this combustion chamber, only 44% of the energy is converted into the work. So what we can do, guys, we can as we don't know this Q haze, so we can easily calculate this Q haze from the thermal efficiency formula, right? Yes. So the thermal efficiency, if you can remember, the thermal efficiency eta T haze, it is equal, this work, okay, so I should write it as this work net output over that Q haze, the hot temperature reservoir, in the heat from the hot temperature reservoir. Okay, so here as we can see, we don't know this, so we can do some cross multiplication like thing, and then we can write this Q haze here, and then this efficiency, it will go here. So let me write it down in a new space. So what we can write, this Q haze, it is actually the work, the net output plus over the eta. So here it is 65 HP, and it is 24%. So as we can't write it 24%, so what we can do, 24 over 100, it was percentage, so we just divide it into 100, right? So now it is 65, and haze P, 1 haze P, it is equal 0.7457 kilowatt. It is actually 1 haze P value, okay? And here, if we do some simple calculation, it will be 0.24, so you can write it as 0.24. So the Q, it will be 202 kilowatt. You can see this. So this is actually, we got the Q haze. That means the amount of energy input we need to get this output 65 HP. So now, you know guys, here this is actually the amount of energy input, and in the question it says determine the fuel consumption rate of this car if the fuel has a heating value of this kilojoule. That means this kilojoule of energy is released for each kg of fuel burn. So now what do we need to do? If we want to calculate the rate, the fuel, the supply energy, the in this question it asks the fuel consumption rate. So what I can write, the fuel consumption rate m dot, let's say fuel, it is that Q haze, that means what is the input and how much heating value you need to burn 1 kg of fuel. So it is 44,000 kilojoule per kg. So Q haze, it is, we got 202 kilojoule, right? And here it is 44,000 kilojoule per kg. So what I can do, it should be kilojoule per second, sorry, it is 202, it was kilowatt, so we just converted it into we just change the unit, that's it. So it will be 16.5 kg per second. Not really, it's not 16.5, it should be, it is okay, I can write it down, kilojoule, and this is kg. So what I can do, I can just eliminate these two terms, kilojoule, and if we do simplification, then it will be 0.00459 kg per second. And now if we want to convert per hour, then we need to multiply, as it is second, we will multiply by 3600, so then it will be kilojoule per hour. You all know actually this, so I'll not explain this. So this is actually 16.5 kg per hour. So what we got here, the rate of the fuel burn, it is 16.5 kg per hour. So that's actually the solution of this problem. So in the question, you see it was given here that 44,000 of kilojoule of energy is released for each kg of fuel burned. So here we just calculate the rate. So this is 16.5 kg per hour. So that's it.